All right, so let's get started. My name is Deepak Cherian. I work at NCAR, which is the National Center for Atmospheric Research. I work in the Climate and Global Dynamics Lab, and I do physical oceanography, so ocean physics, thinking about turbulence and vertical mixing, mostly in the tropical Pacific Ocean. If you've heard about ENSO, El Nino, La Nina, that part of the world. So I think about upper ocean dynamics that is tied to that ENSO side of climate physics. This talk today is a little unprepared, but the high-level idea I'd like to talk about is kind of the effectiveness and the frustration of using metadata in data-intensive analysis. Given my background, this is really climate data, and this notebook walks through oceanography data sets. But I'm hoping a lot of this will generalize because we will talk about using the climate and forecast conventions, which applies to a lot more than just oceanography. Alternative titles for my talk were less data wrangling, more metadata handling, moving from self-describing data sets, NetCDF, to self-describing analyses, and then hopefully I can weave in a story about how I use metadata and why I really like that idea. It's going to talk about a package called XArray. We will get there. I'd like to acknowledge the idea for this package was born from MetPy, and so I stole a bunch of code. And a very large number of people have now contributed to this package, including some in this room, so thank you all for helping me out. Other piece of background, I guess, is this was my first COVID project. I think I started April 2020, because I was bored sitting at home and I needed something to do. So I took this idea and ran with it. Ooh. So question for the room, raise your hands if you've used XArray. That's basically everyone, yeah. Other piece of background is I got very involved in XArray development sometime around 2017, 2018, and I'm now on the maintainer team. Which means I have stickers for a lot of things, including Jupyter and Python, so come up and help yourself at some point. Do you like using XArray? So, okay. What do you like? What do you think XArray helps you with? Like, what does it do? At like high level.
It's way better for multi-dimensional data with metadata. Like, it's better than like just raw NumPy arrays for 3D data sets.
Great answer.
Slicing and dicing are much more intuitive rather than having to know and keep in your mind all the indexing.
Perfect.
Yeah, my experience has been that it's like the most comprehensive for NetCDFs. But I like pandas. I kind of like started trying to use pandas, and then I moved over to XArray because it's just built to handle it, which is nice.
Yeah, like the one-liners, like being able to just do a lot of the commands and stuff like that, sort of in one line.
Anything else that cover?
It's very good for machine learning applications when you're building batches, just because it's lazy, right? So
Okay, you like
for
lazy.
large data sets, that very much helps with machine learning.
Okay. All great answers, and exactly why I like XArray, which is important point that came up there was it has attached metadata, and to me the real reason I fell in love with XArray was that it let me use metadata for my analyses, and then as you pointed out, that ends up making the code very intuitive, and you don't have to keep the indexes in your head. So my model, before I came to XArray and Python, I did my thesis, so 6 years of work in MATLAB, and so that's bare NumPy arrays, right? And I found that I was just keeping stuff in my head all the time. I had to know which dimension was latitude, which was longitude, always fiddling, going between the locations. I want values at 140 west longitude, but then I have to convert that to an index. There was just this pain, right? And so to me, fundamentally, data sets always have attached metadata, right? That's why NetCDF files also are great. They have this ability where you can just stick in arbitrary metadata, on there. And I don't know who what the story is, it was being responsible for this, but the climate and forecast convention metadata, the fact that it's standardized is also an amazing step forward, right? So it's the idea that the data sets have attached metadata. XArray lets you use those metadata, And if you're in this room, you interact with data sets that, to some degree or the other, conform to the climate and forecast conventions. That means you have standardized metadata. And XArray lets you use metadata for your analysis. The idea behind CF XArray is, can we take that one step further and use standardized metadata in some way? So you should be able to run through this notebook. Just a quick illustration of these examples. The first one, I'm just loading a very example air temperature data set here on the left. On the right, you should see a representation of that data set. And this just kind of emphasizes the point that you have a lot of metadata with your data set, right? So there are these air temperature values down here. But if you know that there is, sorry, let me go back. We have dimension names, latitude, time, longitude. We have coordinates, latitude, long, and time. Those coordinate values are actual dimensional locations on the globe, right? So these are latitude 75 to 15 at some spacing. We have nice human-readable timestamps, which is great. And we have arbitrary metadata here on this air variable. Air is not a very descriptive name, but you click that little thing and you see all this extra metadata. It tells you this is air temperature at some sigma level with units of degrees Kelvin. So I've learned a lot about my data set, even though I wasn't the one that created this one, right? So right. And so without metadata, you have to keep all of this stuff in your head, right? Like the fact that there's a 3D array, the 3 dimensions have names and in a specific order. I remember always looking at lat long data set and being like, oh, this dimension is longer. That means it must be the longitude dimension, right? And that dimension is shorter. It's a lot better once you can assign names to these things. You usually know the locations where you have a data, so lat long grid and timestamps. And you also know the timestamp, so there's also a time vector. And like I said, you guys already answered this, but just quickly, the point of XArray is that you can use that metadata. So here's how I would just make a plot, right? So I would have, in theory, 3 arrays, lat, long, and temperature. And I would do something like, this is matplotlib, right? P color mesh, temp, 0. And I get this plot. This plot is kind of useless, right? You don't know what's on the x-axis. You could guess that it's the longitude. The y-axis may be latitude. I don't know. And what's the 0 here? Unclear. Magic constant. Maybe I could guess that, oh, that's maybe the first time step, right? I could make this better because I know a bunch of information. So I could do long, lat, temp, and that would be great. But here's how you would do it in XArray, right? Scroll all the way down. You say dataset.air. I picked out the air variable. I'm selecting iCell means select the index, time equals 0, right? So first time step, and I said .plot. You do that, you get the plot on the right, and you should see a lot of metadata up there, right? You know what the timestamp is. We know that the y-axis is latitude. It goes from whatever to whatever. The x-axis is longitude. It's got units, degrees east, degrees north. It's got a color bar, and the color bar hopefully has a label that has units as well as a description of the data. And so the story piece of this is I rely on this functionality every single day when I do my research work because I'm always making figures. And they're kind of throwaway figures for the most part, right? But I'm always trying things. And I'm always jumping between projects. And so it is essential that when I come back to the thing a week or 2 later, or maybe even months later, that I remember what I did. And it's important that the code is readable, right? And so in my experience, I have found that coming back to read XArray code is usually fairly readable because you kind of know, all right, I have selected the first time index and I call that plot. And if I were to just look at the images, I can see, all right, timestamps here. I know what the axes are. I know what the units are. This is making sense to me. And so this is partly why I really fell in love with XArray, was that it made it really easy to make fairly informative plots with very little work. Because a lot of the metadata is stored on your data set. And it lets you transfer that into like very useful forms for consumption later. And again, so the rest of the bit is of this little section was just to kind of emphasize that point that you can use metadata, right? So here's .cell. So this means I'm selecting the day, 2013 May. So I'm selecting a whole month of values from that data set, and you get something on the right? So if you looked at the timestamps, you should see it going from May 1st. Oops, go scroll a while, but it will go to the end of May. and I think this was the point that was brought up in the room, you can keep doing all of this stuff, right? So when you think about analysis you want to do, you usually think I need to look at the values for May of 2013 at this and this location, right? And instead of translating that into select these indexes, you just have XArray do it for you. And XArray can do that because of all the metadata that was in your data set. So it's letting you use this metadata to save you a lot of time. And what I've found in personal experience, a lot more readable code. Like, I can come back to this. There's no mysterious index. I'm like, all right, I've picked out 240 degrees east. And I just picked the nearest value because that's all I cared. All right, so that was just kind of setting the context for XArray and how that ties to the theme of metadata. The wider context I think all of us are working in is there's this big increase in size and number of available data sets, right? So you can, I don't have a figure, but there's all these plots of like petabytes and petabytes are just coming in and they're all being like piped into the cloud and all of these data sets. It's all great. And there's a lot of effort that's being aimed at handling increasing size of data. Raise your hand if you know the package Dask. It's a good fraction of the room, right? So that's a package that lets you analyze larger than memory data sets with parallelism, right? And so there's a lot of effort at like making it easy to handle these terabytes and petabytes. But there is a problem because there's also not just an increase in size, but also an increase in number. The sensors that we use to sense the Earth have just gone up. There's a lot more satellites. There's a lot more data streams coming in. There's a lot more models. We have a lot more computing power, so we're running those models more and more. And each of those data sets comes with its own special snowflake nomenclature, right? So there's always long, like here are some examples, real examples, I should say. How do you name the longitude axis? I have seen all of these in data sets, right? And how do you name the temperature variable? Like this is very common in oceanography. Temp, theta, temp, depending on how you like to capitalize and how much you like your caps lock key, you can get all kinds of things. And so the step 0, really, of any analysis is let's first rename everything to my favorite names, right? Has anyone had that experience? Do you struggle with this? Yes, lots of nods. Yeah, really painful. And I think one way this manifests itself is there's a lot of people you take in a data stream and you rename it and then you save it someplace. So you can come back and you just have your, like on this laptop, I have a folder called datasets that has a bunch of datasets stored in base that I like it, right? With nice names and variable names. So can we do better, right? And so like I said, XArray lets you use metadata. But the fact that we work in general the field of climate means that we have this giant advantage that a lot of people thinking far ahead came up with this idea of standardized conventions that describe the data, right? And so standardized metadata can help us. And the idea behind this package, CF XArray, is to use CF convention metadata to write down your analysis pipelines and take take the idea of using metadata one step further ahead. So let's look at that a little more closely. I'm going to read some data. So these are ocean model data sets. I actually tried to hit some cloud data sets, but it gets really frustrating. And so what I've done instead was I took some data, subset it, put it on GitHub, and there's some magic here just to read it. But it should all execute on your notebooks, and you should be able to do it. I'm hoping that I can demonstrate some ideas and techniques, and then if you have time, you can try it out on a data set that you like and know. And if we run out of time, I'm hoping that you can go back and the next time you start a new project or you're looking at a new data set, you can try out some of these ideas. So, MOM6. This data set is called MOM6 because it runs the ocean model MOM6. It's got a lot of stuff here, right? But there's fundamentally 2 data variables. I just took out tau x and tau y. What are those variables? Let's look at the metadata. There's a long name attribute, zonal surface stress. There's a standard name, which is, like I said, now standardized metadata, which is surface downward x stress. It has units of Pascal. It's great. You can look at tau y, and it's basically surface downward y stress. So this is wind stress exerted on the ocean surface in units of pascals. So this on the right here is what XArray tells you, right? So this is great. let's use CFXArray. So here, there's two packages I've used. I've used this package called Rich, which lets you do fancier text representations, and CFXArray. And so once you import CFXArray, it should all work on the Conda environment on the Jupyter Hub. It registers a thing called .cf. So on any XArray object, you can call .cf. Ooh, I'm confused about what happened.
Loaded it, then you'd have to reload it.
This should all have colors on the right. I don't know what's happened. Well, let me just restart and run through here. I forgot to do that. All right. Can one of you run this on your laptops and tell me if you see colors in the output?
Yep.
Oh, you all got it. Sweet.
Change it to reload.
Oh, there it is. Great. Thank you. All right. I've made this choice to do it split screen, but maybe that wasn't the best. Let's see. All right. So this is now back to your standard view where you type on the top and output comes below. And so this is a very informative wrapper. What it's got in blue are attributes that CFXArray found, standardized metadata that it found in your data set. What's in these lists here are actual variable names. So things like XH, XQ, lon H, lon Q, that's the terminology that this model uses for its latitude and longitude arrays. What's in blue are actually standardized CF convention metadata. So let's look at one. Oops. Look at one of these variables. So I'm going to look at lat h. I'll look at the attributes. You see, it has something called Cartesian axis y. This is not compliant. It should be axis y. It has a long name latitude, but it has standard units of degrees underscore naught. That turns out to be the standard for how you mark latitude units. And so what CFXArray does is it goes through every variable that you have. It looks at these attributes, and within it, it's got a list of things it knows how to interpret, which in this case, specifically units, degrees naught. Any variable with that gets labeled as the latitude variable. It also knows how to handle Cartesian axis. I taught it to do that. Really, this should be axis y. So this is where the frustrating part of it is. Not data sets don't always conform. They kind of conform. But we can work around these things. And so what CFXArray has done is going to say, all right, this thing is axis y, and it's got units, degrees naught, which means lat h. Lat h is going to be in this list for y. It's also in this list for latitude. So that's how it's done it, right? And the other thing I'll point out here is this thing called standard names. So I'm going to look at taux.adders. It's got a bunch of stuff, but here's the important one. Standard name, surface downward x stress. Right? So that turns out there is a table of standardized vocabulary for most geophysical fields. And so this is actually conformant. And so the idea with CFXArray is with normal XArray, you would use these variable names on the right-hand side of all of these, right? The values in this list. If you wanted tau x, you would ask it for tau x. With CFXArray, you can use the things that are in blue. So you can ask it for axis x, or longitude coordinates, or the surface downward x stress variable, and we'll give it back to you. Right. I'm also going to open the second data set, but let's just do that quickly and move on. So like here. So usually you would do, whoops, that's a typo. Usually if you wanted tau y, I would do mom6 tau y, right? Give me the tau underscore y variable. But tau y, it can be named differently. In this other data set that I read, this was tau underscore y. All right. If I went back to mom6, it was tau y, no underscore, right? So tau underscore y was this tau y. All this adds overhead when you're trying to do your analysis code, right? But you could call .cf, surface downward y stress. Oh, hey, it got me tau y. It's very cool. And the way, again, it's done that is it just looks through attributes. It's like, all right, surface downward y stress. I found that in the standard name attribute. Good. Let's send that back to the user. You can do it for this other data set, CM26. I got these typos in here. again, I asked it again. This is a standard name, surface downward y stress, and it gave me back tau underscore y. So that's really the whole point of this talk. There exists standardized metadata, there exists standardized vocabulary, and the point of this extension package for XArray is that it lets you use that standardized metadata for the stuff you need to do and reduces all this pain of dealing with underscores and caps lock and capitals here, there, everywhere, right? And coincidentally, I just benefited from this very recently. So 3 days ago, there's a field program that's taking off in the Indian Ocean in a few days. There's a big cyclone warning, so it may be delayed. But over the weekend, someone sent me an email, hey, we finally got access to this forecast data from this model that I've never worked with, and can you make some plots quickly? I was like, sure. Opened it up. The first thing I do is always, I hit .cf, and then it tells me, all right, these are all the variables that I know about. Great. And then I just started making plots. I would do, let's see, mom6 dot. This is why you should prepare for your talks. So, I would just do something like this. It was great. You could start to see these variables, right? But the point is, this was a model data set that I hadn't used before. It had its own variable names for x and y. It had like xt underscore I, and then yu underscore j. It was all kinds of weird, right? And instead of me having to constantly fix and correct myself, I just started using CF XArray and said axis equals x on the x-axis, please. And it just figured it out as long as it could do that. And so in practice, what I found is the code is a lot more readable. A lot of times, you can kind of tell that tau x is the wind stress, but in many cases, this is not always true. But I also just find this a lot more readable. I can come back to this a few years later, like, okay, surface downward x stress. I know what that means. I can look at code that uses latitude or longitude and then figure out, okay, I took the mean along latitude. That makes sense. I took the mean along y, and then I make the plot, right? And so that's exactly what we'll do now. Right. So this, to me at least, was like a giant improvement once I coded it up. And so here's a illustration of how I do these things. So here I'm looping over the two data sets we loaded in, mom6, cm26. I selected the surface downward y stress. Remember, normally you would select tau underscore y and then tau y, and you have to remember which one is which, right? Don't have to do that anymore. I just pick the first time instant. That was somewhat an arbitrary choice. I really wanted to do dot mean time, but there's not that much data, so whatever. And then I say, all right, let's take the longitude mean. So in this case, I'm going to say I'm going to take the mean along the axis x. And finally, I'm going to make a plot. And so who finds this readable? Like, can you kind of tell what was happening there just by looking at it? General nods? Yep. Yeah. So to me, this was like a major advance, right? Like instead of figuring out for each one and doing it, all the time, you could have this function as a little plot wind stress mean x and just call it on any data set. As long as it has the attributes and you can figure it out, it will basically always work. There's a little more magic that's going on in here. A few things to point out. You'll notice that .cf is basically always repeated. So what happens here is it picks back, it gives you an XArray data object, so then you need to call .cf on that. So it's a little repetitive, but it's at least very clear. You can, so I could also do this and it would work, right? So you can kind of intermix stuff that uses standardized metadata versus stuff that does not. There's standard XArray code. So it kind of just like plugs it. You can use it, sprinkle it at places that it works, right? The other thing that is done, which is not obvious, is when you call .cf.plot, you'll notice that the latitude is on the y-axis and the data, tau x, tau y, is on the x-axis. So it's gone and done this automatically. Like if I remove the .cf, look at that. The y-axis is the dependent variable, which is usually what you want. But the x-axis is latitude. To me, I almost never want that. I actually do want, hey, if you have the latitude, please put it on the y-axis for me. That's how I'm used to interpreting this data, right? So it's done that automatically. It looks at it and says, okay, I have one dimension to plot. It's the latitude dimension. I'm going to put that on the y-axis, and it makes this choice for you. Again, Saves you a little bit of time, right? You didn't have to type the y equals y or whatever. It just does that automatically. Does anyone think that was cool? Any questions so far?
Yeah, I'm not too familiar with this, but for the syntax, would that not work if like you remove those end parentheses?
You mean these for
are those required?
Yeah.
If you're doing that syntax?
Yeah. Okay, I see what you're saying. Yes. So this is. So yeah, this is Python syntax because it's really one very long line that's just been broken up. So the way to read it is like a pipeline. So you take the surface downward y stress, and then you select the first time instant, then you took the mean along the x-axis, and then you plot. So it's.
Okay, now that you mentioned that, now I'm seeing that.
Yeah. Sorry. Yes. I think some people call it the fluent style of coding. But it's like this idea of pipelines and data flows. So you can write these long lines without having to use like 4 different variable names, right? It's just a pipeline. So yeah.
I guess this all looks great, sounds great. Like, is there a catch? What's the downside? Or you just gotta write CF all the time? Like, is that, like, that's fairly free?
The catch is what attributes exist on your data set.
Okay.
And so that I'll get to that. And that is really painful. And that's why I say the unreasonable frustration, because it could be so good, but it's really hard to get it right.
And then I guess my other question is, can you export like a CF to NetCDF? Like with the labels replaced with the normal labels?
Like standardized names?
Yeah, it's interesting. Instead of like tau underscore x, tau not underscored x, can you just use, like pull it in, use CF XArray, then export it with the standardized labels?
No, yet. I have not added that.
Okay.
There's an open feature request. So like you could, in theory, call rename and set tau x to be surface downward x stress, right? And like, yeah. No, but it could be easy to add. You should add.
Yeah.
Pull requests are welcome.
Community support is needed. Okay,
The
got
problem
it.
is subs, there are certain cases where multiple variables have the same standard name.
Yes.
Got it.
And then you have to figure out how you tell those apart.
Yes. John was a big help in getting this off the ground. He knows a lot.
Sorry for.
No, you should tell it. This is a discussion forum. Less of a talk. All right, so that's one very simple example, right? But it shows you that you can pull out variables by a standard name. You can do common operations, but basically every operation. Not everything is like fully fleshed out. If you find something that doesn't work, definitely raise an issue. But most things like .cf.mean along the x-axis, it will translate that to the appropriate x variable name and do the right thing. If it doesn't, usually it'll raise an error, and so and you can always go back to doing normal XArray and move on with your life, right? And it does the plotting, and it has a bunch of automagic stuff that it does there. Quick demos. So let's get the x vector. So you do .cf square brackets x. Look, it picked out the variable that was called xh for this particular data set. But you can just keep putting this in your code, and suddenly your analysis code does not have to be specialized to a particular data set, right? That's the idea. Somebody mentioned indexing as a big help that XArray provided. So CF XArray, you can do the same indexing. You can give it. This was not what was intended. I wanted to do that. It should give me an error. Sorry. Right, so I said give me the x equals -140 and latitude equals 0. 0, 140 is a point in the tropical Pacific that I work with a lot, so that's why it's there. But you can see, right, it's translated x to xh. It's translated latitude to yq. These are all things that I didn't have to remember. I just asked it for 0 and -140. Just give me the nearest point, that's fine. And it did it for me, right? Already demoed this, but you can have it take the mean along the x and y axes, and you get back a time series. And again, I didn't have to remember xh, yq, whatnot. This is particularly, it can be useful for model output that's on a staggered grid. So they're always at different points. For many cases, I found this very useful, especially for very simple things like just take the mean. I just want to look at the mean to make sure it's sensible. You can go a step further. There's a package called XGCM that understands staggered grids and will interpret conventions and let you, generalize a little more. But CFXArray just sticks very simple. It's pretty dumb, actually. Every time you run it, it runs through a list. And like, all right, X is in the hard-coded list of special access names. And you're like, all right, this variable was tagged with access X. Let's get that and substitute that name in there and just passes it on to XArray. So it's just like a little layer, lets you interpret standardized metadata, and you can kind of drop in, drop out as and when it works for you. Right? So this is all great. Hopefully that's given a flavor. Question?
Another CF library to do all the interpretation, or are you doing it?
No.
As a package? You're not using the CF data model package, or?
No.
Okay.
It's very simple.
Okay. Yep.
Yeah. Okay. So what's all of that is great. What are the frustrations? It is very common to have incomplete metadata. The public data sets I was hitting, as an example, it had 23 data variables, and then I hit .cf and I only saw 7. So 16 of them did not have standard names. And in some cases there is no standard name. In some cases there was, but the model just doesn't spit it out, right? There can be lots of missing attributes. In writing this package and using it, I've slowly, organically built up a lot of knowledge of what attributes could be added. And now anytime I look at a data set, I'm like, you could be so much better. Because this talk is focused on writing analysis code, but attributes are important in just knowing what you have, right? Like it's important to have things like units specified and standard names and like descriptions and like there's conventions on how to specify these things. Takes a bunch of work, but once it's there, it's super useful. And yes, not everything is standardized. Sometimes no attributes apply to what you want to do, in which case you have to come up with your own little convention, right? And you're back to it. The second issue is dataset metadata optimizes for self-describing datasets. That means that some attributes can be redundant. This is a little more like in model world. But let's look at it, right? So if you call .axes, you get x, y, z, and t. And if you call coordinates, you'll get longitude, latitude, vertical, and time. And you notice that both are the same, right? And there's a detail here. All right, so here's the data set. And it's got xh, xq, these are 1D. You'll notice that the data variables have those dimensions x and y, right? No lat, no lon. It's x and y. And what's also here is geolat and geolon that are 2D. And so what's happening is the model is discretized on a sphere, and so it's got a nice little curvilinear grid. And so the x dimension, technically the values of longitude at which you know the values change with latitude, right? There's like a 2D. Inherent 2D-ness to the coordinates. And our metadata over here don't tell us that. They give us these 1D coordinate values, but they don't tell us about geolat and geolon, which I think would be useful latitude and longitude when I want to plot something. When I want to take the mean along the x-axis, yes, xh and xq are useful. And then lon h and lon q are more or less useless. They're a nominal latitude that makes no sense once you get far away from the equator, and they're not a dimension of the actual data, so their usefulness is kind of limited. So this is the kind of frustration that I tend to struggle with, is like differentiating between an axis or a dimension, referring to the dimension of your data set, versus referring to the actual grid that could be useful when you plot things and you care about how things are projected on the sphere. And it all just comes down to metadata. Like it's possible to tag xh and xq with axis x, and yh and yq with axis y. And then I would do geolat and geolon as my latitude and longitude variables. And then I can say, all right, take me the mean along x, that's sensible, and then plot along latitude. That's also sensible, right? It would all work quite nicely. So this is the kind of drawback, right? And so in practice, I find that I am always standardizing in some way.
Sorry, I suspect there's information in there about how those latitudes and longitudes connect. In CF, there's like the grid mapping attributes, and those connect a lot of these things, I think.
Yeah, so grid mapping is not on here, and particularly frustrating. The units on latitude are just degree.
Oh, okay, yes, right.
The information, the metadata is there. It's in the long name attribute, but that can be kind of arbitrary. There are no rules there, right?
Yeah.
Yeah, I was just basically saying it's like, just because it starts to implement CF
Yeah.
stuff, you know very well is that CF has things that can be used,
Right,
that
right,
doesn't
right,
mean
yeah.
the data set's using it.
So this, you asked what the catch was, right? This is the catch. It's like, sometimes the metadata is there, but it's not really in a usable form. It's kind of confusing.
What's the data from?
This is from a model called MOM6, which is an ocean model, modular ocean model 6, version 6. It has a mode where you can turn on extra CF compliance. I have discovered this. And
That's not the default mode.
no, because these models have like long history, right? So like in the past it was called Cartesian axis, so they still call it Cartesian axis.
Before CF.
Or they just, yeah, I don't know. I don't know what the history is.
decided to care about CF.
But on your idea of something that tells relationships or coordinate points to each other, there is this thing called the S-grid conventions, which a couple of ocean models use. ROMs there is one. That tells you where points are related to each other for the staggered grid. There's something for unstructured grids called U-grids too. But yeah, I mean, we're really lucky. I've talked to at least one friend of mine who's in plasma physics who just struggles with every single model just doing everything completely differently with no standardized metadata. And it's hard to even start. Right? You have to know what those things refer to, right? So can't complain too much. We have a massive advantage. And like I said, one of these ideas is self-describing data sets, which is very cool, but sometimes it can get pretty bizarre. So here's what's called CMOR, which is the climate model output rewriter, right? So this problem has existed for a long time, right? So when you do like ensemble analysis of a bunch of climate models, you end up with the same problem, tau x versus tau underscore x. And so there's a standardized vocabulary, it's called CMOR, and it has things like diff tr blo. The CF standard name for that is ocean tracer diffusivity due to parameterized mesoscale advection. So that is very self-describing, and it makes sense to an oceanographer what that means. But it's also really long, right? I don't want to type it. So this is where, it kind of, 4 underscores I've found is my personal limit, right? And so there is this other convention, which I haven't added support for, but potentially you could do some mapping and try and figure it out. Like maybe you can do this. But this is, I find to be too short. Like what is diff tr blo? Yeah. So this is where it can kind of you hit, right? So at some point you're still renaming things to the same variable names. That makes sense for you. And then last frustration, sometimes it's just wrong. I already pointed this out. But if you look for geolon, the units are degree versus xh and lonh have degrees east. Degrees east is what we want, right? Okay, I think we're kind of out of time, unfortunately. But so in practice, what do I do, right? Ever since I wrote this package, my workflow has changed. I tend to now read in data sets. Previously, I would rename them to my favorite names. Now I just add attributes. And I add standard names. Sometimes I make them up, but make sure that they're kind of short that I can refer to them, right? And then I write as much generalized code as I can. Yeah, there are limits, but it really tends to work. Here's an example. So this is a little screenshot here, seawater thermal expansion coefficient. That is actually a standard name. I pulled that out of the data set to alpha, beta. I do some stuff. But this is how my code looks now. Is instead of renaming stuff, I'll ask it, give me the variable with this standard name, and it gives it back to me. If it doesn't work, it will raise an error. So then I go in and I add the attribute to the variable I know, and then things just move on. Ocean vertical heat diffusivity, that's another one. And then I do some calculations with it, which is great. And this one actually, yeah, ocean vertical diffusive buoyancy flux is also a standard name. And so you can see me adding that attribute. Like I calculated this thing, here's the standard name. Now in the rest of my pipeline, I will use the standard name throughout and move on from there. I also use it for things like error checking and validation. Here, it's demonstrating that I'm looping over all Z coordinate variables, and I'm ensuring that the positive attribute is up. This is a thing in oceanography. Sometimes you'll have pressure increasing downwards, so positive is downwards, and sometimes you'll have Z, which is sometimes also positive downwards. They just do it at depth below surface, 0, 2, 3, 4, whatever. And sometimes Z is pointing upwards positive, and you have negative depths. All of these are valid, all of these are sensible, but it matters in your code what the sign of Z is. And so you can see me enforcing that, okay, I always want positive up, I want all negative values for my Z, I want to ensure monotonic increasing. But this is where I'm using attributes, right? And I have like a pre-processing step where I make sure those things are right. And if for some reason I give the function something that wasn't pre-processed right, it will tell me, like, oh, I didn't find the positive attribute, or positive is down. Like, your code, you would get bad values, right? I have more examples, but basically, like, error checking validation is another use case that you can think of using these attributes for. So we ran out of time, but here are a couple of quick links so you can click them and go to the documentation. Yeah, so there's a quick start guide. That was the first link. That will just quickly go through basically all the things I showed you. And then there's how to use CFX, right? I demonstrated one way where you just kind of, you use the standardized vocabulary instead of, so things like latitude instead of lat. You can actually get the variable names through various properties and then use those later. You can rename, so you can, I didn't show this, but you could do something like rename the latitude variable to lat_0 or something. The names that you like. You can use the metadata to adapt to your existing pipeline. And it's kind of advanced, but you can actually add custom rules for it to do the mapping between what you tell it and what it tries to find. So it's actually customizable. I didn't show that. And there are a couple of in-depth examples. They're very ocean-specific, but this is totally applicable to climate science, meteorology, anything that you do. We would happily take more examples. But I'll stop there. If you have any questions, comments, thoughts, do you like it? Is it interesting? Do you see it useful, being useful? Yeah. Thank you. Thank you for listening.
I think we do still have 15 more minutes, so
Oh, we do?
we don't have to rush
Oh,
out.
Yeah, I was looking at that too.
Sweet. Well, in that case, as intended. Yeah, okay. So I ran into this problem where I really like you all to try it out. But I realized that not everyone's an oceanographer, and one frustration, despite all the cloud stuff, is that not everything's in the cloud, and then it's all kind of a mess, right? So if you have data sets on your laptop, or you can hit a thread server or something, I'd really love it if you guys could just start, like, this environment should get you started with everything interested, so yeah.
Where is some interesting, are there any good repositories that contain a whole bunch of kind of ocean-based or, you can think about Great Lakes-based water
Data sets?
data sets? Yeah.
Yeah, no, this
Doesn't really exist, yeah, okay.
I had to upload those to just kind of lost. I was iterating with Thomas to making sure that this notebook ran. And I had to like subset it on the cloud, download it, put it on GitHub. And like, yeah, this is like the real a general frustration about all these data sets. It's kind of hard to find out what's where. And like you're always like, let me check this thread server. Let me check that catalog. Yeah.
So I think it's, obviously as an atmospheric scientist, there are big oceans and water plays a huge role in things, but I think it's hard to find good remote data sets that will then weave nicely in with all these other things, because at least on the Atlas side, we have some level of aggregation within various thread servers that are at various institutions, but that seems to be a little bit more coordinated than having some of these easily accessible and in the actual data and not just figures that contain the data. Like, oh great, I can go out and find sea surface temperature anomalies, right? But I want to be able to plot the sea surface temperature anomalies because I want to maybe overlay it with other variables that might be interesting. Like, oh, hey, a hurricane's gone through. I want to see the overturn afterwards. Would be a really neat application, right?
I think I take back my statement. I think if you searched for like ERDAP servers, you should find them. Especially for things like sea surface temperature, like NOAA and NCEI. These places all have.
I use
I use
has a lot of servers.
That's what came to mind. So yeah. Oh, look at that standard name sea surface temperature. So right, for this next 15 minutes, I think if you just try it out on your data set, let me know if you have questions. I'm happy to walk around and yeah, try it out.
Can I ask you a hot take?
Sure.
So with this, why would you use Iris versus CF X-ray / X-ray?
I haven't used Iris in a long time, but in general, Iris moves CF metadata handling into the data model.
Okay.
And so I think you could do a lot more stuff. It has like a deeper understanding of the stuff. CF X-array is very simple layer. Like all it does is take input, map it to something that can be passed on to X-array. Like it's super simple, but it gets you like 80% of the way there. It stops there. So like, I think it takes it a little closer to Iris, but Iris can certainly do a lot more. And has a deeper understanding of the data model. So, yeah. This is very opportunistic. If the attribute is there, you can use it.
Right. Yeah.
Can I just put in a plug for CF? I've been involved in CF for a long time.
Thank you.
And there's a lot of reaction against long standard names, which I understand, but there is, it's kind of hard to do what they're trying to do and keep everything short, because there's several thousand of them now, and there's going to be plenty more. Get involved. Anybody who's not, or who is interested in CF, especially if you're coding stuff, get involved with CF, because it's a very welcoming group. It hasn't had a great, huge vocal community lately, and so I really appreciate this talk. It's really great to hear, and I think that's one of the things I'm trying to push in the CF community is we need to be out there and saying, hey, there's a lot of stuff already here. Let's try to use it and build on it and see where it can go. So, thank you.
Oh, thank you. And your collaborators on the CF conventions. Yeah. It is pretty amazing. Now, somewhere in here, I had a link to the standard name table. There you go. Yeah, this is a long table of standard names that you can look for and use. You can search it, you can subset it. I spent a bunch of time here.
So now you talked a lot about some of the model data here. If you found this works really well with a lot of the observational data sets too, like I guess within like the ocean modeling community or the ocean research community and stuff like that, do people usually use CF conventions quite a bit with observational data as well? And
yes, I think this is actually one step from a data quality checklist is a bunch of attributes. So usually it's not a problem. But it tends to break down, interestingly, is little university research groups that tend to work with MATLAB. MATLAB makes it a pain to write netcdf files. Yeah. And then people are trying to interpret the conventions on their own. This is another place where XArray, it makes it really easy for you to write basically compliant netcdf file. There are some like edge cases, but you can write it and it will look good. I usually find like extra dimension names that are unnecessary, and yeah, there's usually like a little extra work. But no, in general, I think there's usually some attributes of some sort, and they're usually compliant. But usually I want more because now I can actually use them. It's not just for describing what's there, it's also to let me describe what I want to do. And usually I want to do a lot, and so I always want more attributes. I'd also encourage you to go to the documentation. And if you look on the left, like I've given you a very, very brief overview. Like there's things like unit handling. It teaches how you handle the CF style units in XArray. It's got parametric vertical coordinates. This one again is very. This one is a little complicated, but basically there exists standardized formula for going from like a model grid to the actual dimensional vertical values, and like all of that stuff is added. We have some like helpers for bounds variables. Someone recently added support for grid mappings. I don't remember exactly because I don't usually work with those data sets, but if you do, check that out. I added some little support for sgrid and ugrid, which lets you identify the x and y axes of the grid, assuming those are there. Some support for geometry objects. I'm not an expert. Plotting is definitely my favorite feature, so you can scroll through that. There's a lot of stuff there. Let's see. Yeah, and then custom criteria. Basically, you can override criteria. So here, for example, very oceanography, but there are two, or at least, yeah, seawater salinity and seawater practical salinity. Enduring point of pain. But I can override CF_XArray stable to say, hey, when I say seawater salinity, I expect either seawater salinity or seawater practical salinity in the standard name. I will give it back to you. So again, like a little bit of harmonization without me having to go in and tweak it. Yeah, the one thing that I want to add but can't be done yet is doing things like adding cell methods attributes when you take .mean and stuff, or a history attribute that NCO likes to add. So you could imagine it automatically tracking all the operations you do with XArray. Not possible yet, but I really like to do that at some point. But yeah. Do you guys see this being useful?
Definitely, yeah.
What kind of data sets do you work with?
Shipboard data sets. So like it's in situ data, but also we're trying to put it onto NASA's data repository. So it's like a weird combination of trying to get it to work with remote sensing stuff too. And this kind of thing definitely, because remote sensing data and in situ data are usually structured so differently that having the ability just to even go in and look at standard names instead of the variable names is really helpful.
Great.
I think that standard names is the most powerful thing. Big MemPy users, to some extent John solved some of the dimensional name issues that we commonly run into on the atmospheric side, so that then I can just say, oh, give me the vertical coordinate, .MemPy.select vertical, and then because we of course get like 14 different isobaric coordinate variables because absolute vorticity only has 4 levels versus geopotential height that has then 24 or whatever, and you're like, but what would be neat would be to solve kind of that issue where I've got maybe 5 different variables that are otherwise X, Y, Z, maybe T, and but may not all have the same number of vertical levels. Mm-hmm. Because it becomes onerous to then have to select separately by variable, because you can't do that on a data set because they're different. Because it's a different dimension name, where basically like putting in null values for levels to then unify to a certain set, right, would be a very, very powerful thing. It's often in interpolation is where we run into the issues, because some of the moisture variables very high up in the atmosphere, there's fewer levels of it. And so even if you subset down and you actually have all the levels that are the same on all the variables that are real and there's data there, but because the names are different, you then have to manually rename those dimension variables to then be able to easily then use interpolation calculations and stuff. And I mean, this just goes to the larger problem of what data are you saving long term, how are you storing that, what kind of metadata you have to then do that, and so those are the extra challenges.
I had a data set that I was working with that had it was a series of like drifter buoys, and they all had different temperature being taken at different depths, and the temperatures variables in the file were named by what depth they were taken at. So so all those are the standard name like seawater temperature, but of course to actually pull those out, and it was just a mess.
Classic.
So
yes,
this would be extremely helpful. This would be extremely helpful to use for that.
Another frustration is, like you said, metadata in the variable name, or even worse, in the file name.
Mm-hmm.
Very common. So that's where it kind of breaks down.
Yeah, it's funny when you said like, there's 14 vertical indices or whatever, and whatever your data set. I just pulled in a random threads data set that literally was 12. All are in vertical, so. makes like, yeah, it solves a problem. It solves a problem, creates a different one, and yeah. I don't say it's better or worse. It's just different.
How many time coordinates are there?
Yeah, no.
Right. Yeah, there's mentioned too, like, yeah, it also just brings up like the metadata frustration because like different organizations, for example, like the atmospheric radiation measurement program has like a set data standard that doesn't necessarily 100% follow all like the CF conventions and stuff like that.
I see.
So it like makes it, yeah. So
Yeah.
it sort of brings up like some of those like metadata discussions and trying to get things to conform.
Yeah. I think that's why I think of it as unreasonable frustrations. It could be so much better, but it requires coordination, right? And that's really hard. But I guess the other thing I'll plug, the other thing I'll plug is if there are attributes that you think could be interpreted to make your life easier, but it doesn't work now, definitely just open an issue. And yeah, like this stuff just gets better the more people use it and find like edge cases or like things that could help. Yeah. Because yeah, our user base is really, I think, mostly oceanographers at least have helped build it out. So it's hoping more meteorologists also get in. You know? And I think some of you, at least MetPy users, have a bunch of this already, right? So it's yeah. That's a question in the chat.
Keep commenting and agreeing with Kevin, basically, the different dimension variables. I hope I summarized that pretty deep.
Do we have a MetPy issue open for that?
I think I have one that is baked in there for potentially like a function that just says, I want kind of standard, temperature, geopotential height, relative humidity, UV, winds, that then will basically give me back the subset over the 1,000 to 90 millibar type thing or something like that. I'm pretty sure it's in there somewhere. Oh, line coordinate data for multiple variables. Look at that, $15.99.
Could you put that in the chat? I like
Sure.
It'd be nice to say Z rather than isentropic level 14 or something. You should be able to just do that, assuming it has axis Z.
Yeah.
There.
But this is sort of in particular, it's like, okay, we want to have all these different variables on common analysis levels or common plotting levels.
I've run into a similar thing in the horizontal with staggered grids. Like the U's are in V's that are different places, but then say I want kinetic energy, I want to like interpolate to the center. So XGCM helps with that very well. You can say interpolate to on the axis X to the center point, and it'll do it. So I've been using a lot of that, and that again it's built on metadata too. It's a little more explicit. It will try and auto detect now from SGrid, but worst case you just tell it, and then it helps you get around that. So yeah, the stuff is all like 80% there, 60 to 80% there. And it's very useful, so definitely just try it out and see how it goes.
Actually, we've reached the break time.
Perfect.
So we are scheduled for a 15-minute break at this point. Obviously, you're free to finish up what you're doing and use that break however you like. We're going to reconvene in the main room at 2:30. So you know, don't want to interrupt you from doing what you're doing here, but that's the schedule.
Great, thank you. I'm happy to. I was just planning to hang around for the afternoon, so people have questions. Help yourself to stickers. Thank you.